Okay, I've decided, I'm not English, I'm Afrikaans speaking. My name is Isak van der Westeren, and I've decided to make this little video to carry a message to people that is of great importance. South Africa has has a very long coastline in relationship to its area, and it is in one of the highest wave energy flux waters in the world, like southern Australia and certain other parts of the world. But there's only a few parts that can actually compete with us, maybe southern Australia and some other places. We are ideally suited for wave energy, and that is something people should know as an alternative form of energy to solve our problems. Wave energy is an emergent technology or emerging, and it is convergent at this stage, the designs of the wave energy converter. So we need more physics and maybe AI involved in the research. What I suggest we do is start a wave energy research business operation in South Africa that is not only, or some form of research that is not only dominated by government but by the private sector for our country as a whole and for the world at large, so we can get international cooperation to solve this once and for all, do comparative testing and so on. We also would need theoretical testing and also AI maybe and deep learning kind of computer simulations. So it's a bit big for me to handle on my own, and I'm not going to even try. But I do have some ideas, but obviously it must be optimized. Now, to do this, there will be a need for a wave tanks of certain shapes. You can have channel tanks, wave makers. A tank I propose to maybe for there's three levels of wave energy research needed for the different water depths. Three types of water depths you can work at. You get your near shore or near the coastline, or even where the water is near breaking water. Wave breaks, né? So you don't want to generate energy after the point that the wave breaks. So that will be deeper than the break point of the waves, or the deepest point waves can ever break. And then you need storm resistance. You must think of that. You must survive storms, the WECs, whatever you design. But the three levels is near shore, onshore, that's close to the beach. Near shore, that's a bit deeper, like 25, 50 meters, that kind of depth. It's near shore and offshore. Okay. Okay, what I proposed is maybe one thing you should know about waves, they are extremely efficient. So that makes it actually easy to model and understand waves. A thing you should know is if you have, say, only look at incoming wave and reflected wave energy, or look at the energy of the power in the waves. If you have take the incoming wave energy as 100% for a certain wave or condition, that may be a monotone wave or variant, but you take that energy as 100% and you try to respond per wave ultimately. As it's variant, it makes it more difficult. But say you use monotone waves, your wave maker is now set up long monotone waves for research purposes, and you reflect 100% of the waves with a wall, you will get like a 0% that you can extract, because all the 100% comes in a certain direction. 100% gets basically reflected with very little losses. You can assume your losses between 10 and 5% or less, like a few percent. So you can like consider that as zero. Okay, so you can make the prediction that if you design your things smooth and well interacting with the waves, you can consider your frictional losses, or due to viscosity and things like that, you can consider those losses as approaching zero due to the high efficiency of wave interactions. The water kind of knows what it should do to have the least amount of losses. But the thing like a dollars is designed to shatter waves and to work let the shattered wave, the water movement becomes so chaotic and complex that basically the wave works against itself, and it disperses the energy as heat and maybe water evaporation and stuff like that. The water is obviously cooling itself, so you will not really see a heat build up or anything, but the water absorbs, so that heat and the temperature rise will be negligible because of the high specific heat of water. You can say that you need a lot of energy to rise the temperature of a liter of water by a degree Celsius, say. So it's got a very high specific heat, and you will not see much of a heating effect due to water breaking on a breakwater like dollars, because of the large amount of water involved. But it's fair to say that it becomes heat eventually. Okay, but that is only in that case where you have a thing that shatter and break the water energy up. But normally, if you have well interacting systems like wave power devices, you will not have much of a problem like that. So the losses due to that will approach zero. And due to that, it's easy to do research on it. So say you only look at incoming wave and reflected wave energy. Incoming is 100%, reflected can be anything. Your 100% reflection will happen when you have an obstacle in the wave that completely blocks, stops the wave and turn it around, reflect it. So like a certain curved wall with a smooth surface, very low friction, water friction on the surface, maybe something like a fatty surface, like some fatty paint, like water off a duck's feathers, like that kind of smooth surface. A wall coated with that, with a certain curvature, like a ramp up idea. That wave, when it hits that wall, or even an upright wall, it will ramp up or jump up against the wall when it hits and impacts each wave crest, and it will basically under gravity fall back and get reflected nearly 100% back. So the reflected energy will be about 100% of your incoming energy, or 98%, or something like in that scale. But we don't care much about 5 and 10%, you understand. When we do this kind of research, we're worried about getting optimal theory, and so small losses can be ignored. We're looking at they're just very good systems. So, okay, so a wall will be 100% reflected, but obviously you cannot generate energy like that if you don't load the waves in somehow. But we reflect now 100% back, so there's no other source of energy loss. Everything gets reflected, nothing gets absorbed in any way. And that is the one extreme. The other extreme is when you simply have no barrier and the wave just passes through, right through, nothing gets reflected, everything goes to a dollars at the far end. But we're looking at this point, the WEC point, where the device is actually supposed to be, but there's no device there, so it just passes. It's like regular sea or regular wave tank, any part of the wave tank where the wave actually travels. That will be the two extremes. Somewhere in the middle there's a peak, a power peak that you can actually extract energy. Now say you it worked out to be, with some research, I'm not sure, but it's a good guess, and I think it's actually correct, that at 50% absorption, so either it passes through, or some part passes through, like the other 25% gets absorbed, 25 passes through, 50% gets reflected. So 50 plus 25 plus 25 is 100%, so all the energy is accounted for. But as you can see, you can kind of account energy here. You can say this plus this plus this makes up the 100%. And that is nice because the frictional kind of losses approaches to zero, so it makes it easy to know you're doing this. This is passing. This is what is absorbed by the dynamic shock absorbing system. That is actually regenerative. Maybe you need to obviously want to extract energy out of this wave movement, like a dynamic shock absorber or a regenerative shock absorber kind of principle. And obviously want to optimize such a regenerative shock absorber for a nearshore device, but or a point absorber, and that's actually what everything is about. And I just want to say that because force times distance is energy, if you have a certain wave crest or some movement coming in, a bump, call it that, that's basically a wave moving a float, say, or a roller on a ramp, you want to apply the right kind of, you can either do it by prediction or you can do dynamically load it, but you want to apply the right force and then a distance happens. You see that you cannot always predict, but the right force at least, dynamically, to get the best force times distance product, to get maximum energy transfer without reflecting too much wave energy. And you don't want to reflect probably more than 50%. Say no energy gets passed by this WEC you are now working on, or certain percentage can pass, but normally you don't want to have energy passing your system because that's just a dead loss. So you would like rather to have all the energy hit you, you reflect it with some ramp or a reflector, or as I say, a collector, a lens effect for deep sea. You absorb the energy and you reflect some of the energy, but you want to do that absorb part very efficiently so that you don't have a lot of movement but no loading. So you want to apply the correct loading to get like 50% reflection. And that kind of research can only be done if one knows what to look for, and that is the kind of concepts you use to develop wave energy converters. You understand? And a nice way to do the correct loading is by parallel digital selection, no, binary selection, sorry. So you have a lot of things that say can need a certain force to push in, but it actually generates electricity or of energy in a form we can use. But you need this force to push it in, to operate it, no matter the stroke length. You need a fixed force on each of them. Say some like a hydraulic cylinder against a fixed power station pressure, because you cannot vary your power station pressures. You connect 1,000 units together, 100 units together. That operational pressure, whatever it is going to be a fixed pressure. And your power station is going to run at 60 bar, 100 bar, 50 bar, whatever. That's your hydraulic pressure, your high pressure, seawater pressure, and that pressure is not going to, you want to vary that too much. You can have a band in which it can vary, but you at this moment you're now working on, your controller can check that also, but that is like non-variant. So obviously to vary your force with a cylinder, say you have to vary the area of the cylinder's piston, but that's impossible mechanically to do that. So the only way to do it is to use a digital technique that you have a cylinder of say size 1, the next cylinder is double that, that's a size 2 cylinder, the next cylinder is say a size 4, size 8, size 16, size 32. If you take it from 1, the area of the piston, then you will have a 32, 64, 128, and so you can go on. But obviously you want to use a byte or something with 256 different area levels that you can select with only 8 cylinders. That's a kind of concept of digital, of binary selection. So you can either bleed the cylinder so it doesn't really have any roll, it doesn't pump, it doesn't have one-way valves that pump, it sucks in through a one-way valve, it pushes out through a one-way valve so it actually can pump, or you can do the power station, or you can bleed the cylinder or decompress the cylinder and it actually just move with, or you can even decouple it mechanically so it doesn't move with the stroking of a waving. that is operating it. So you can set the right loading factor of 256 levels. So obviously you can have levels, that's fine. That's a lot of levels. That's a lot of gears. You can see it as gears. A car only have 5 gears, 6 gears maybe. Some trucks have more, but 16 up to 16. But 256 is a hell of a lot of gears. Now obviously you want a multi selection ratio. You understand? Of multi counter force for maximum energy transfer purposes. And to this binary selection will be a nice way. If you cannot physically change the area, you can have a parallel of 8 cylinders that can do the trick by selecting and deselecting the cylinder by either you decouple it or you couple it by this decompression. So the cylinder pumps, but it actually does just pump in a circle. But it doesn't actually pump against a pressure to the power station. So it moves easily. You understand? So say we have assumed the friction of the cylinder is 0. But in practice, that kind of same thing can be used maybe for a electromechanical moving a magnet in a coil. But I think that will not be so linear like a cylinder. But the fact is, we can learn this kind of right force to apply against a certain movement over a distance to get the best energy extraction for a kind of shock absorbing device. It can be used in electrical cars and electrical trucks or vehicles to build the regenerative shock absorbers. A whole theory can be, or a mechanism and theory behind it, or a control regime can be developed for this. And we kind of need this for wave energy research purposes and to optimize the WEC design for the future, so that you can, instead of diverse technology, and as I said, very few people actually use prediction. That is kind of very useful if you can predict just in time your size of your incoming wave or your category of your incoming wave if you are in a directional situation. Obviously, it will become more complex as you go deeper water, because in the direction of the waves become more a wider angle. Like in very deep water, the wave you can expect waves from all angles, and we definitely need research for this. So I'm going to stop this video, and I say thank you very much for your time. But I really want us to take wave energy and this kind of research serious, and see how we can do this proper loading, if force loading, to obviously you measure your actual distance moved afterwards and compute the force times distance is energy per wave cycle, so that you can get optimal, and you can ignore the noise. Basically, they're small in relationship to the waves normally, but you must vary the wave crest, wave amplitude, and you must vary the wave length within the band of, say, wind-driven waves in the sea that you can expect. You must know we're going to do this in the sea eventually. We know the frequency band. We don't worry about small little ripples and smaller waves that can be ignored because their energy is so low that it's below the threshold. There's an upper threshold that if you start seeing waves exceeding that, you must your device must have the capability of either folding under the waves or something, so it can survive storms, because obviously you want a very long-lasting system, or a very cheap system that is not so long-lasting, but it must be cost-effective eventually. Now, with wave energy, your installation cost will probably be very high eventually, but as the units perish or fail, but so you might want units that has parts that is easily replaceable or hard wearing, so that these parts can be replaced, but the rest of the system remains. That may be much more expensive, but obviously you want cost-effective solution to this problem, so your units must not overall be too expensive, and they must at least pay themselves by generating energy that is worth more than the unit cost itself. And that is kind of hard to do with wave energy, but it's not impossible, because if your sea conditions is not that rough, people think, okay, it's not worth it. Now, well, it's still worth it because it generates energy, so it's worth it. But then if you say your sea conditions half as calm as another place that is optimal, your system lasts 2 times longer, then it's kind of the same. So the sea is the one thing that destroys your systems. So rough seas accounts to a shorter lifespan for a WEC unit overall, and calmer conditions double your lifetime, basically, maybe half as calm, like double the lifetime. So kind of reasoning you should try to apply here, or some curvature, then that would mean, as long as it's close to that, that would mean it's quite viable to do wave energy in a very wide variety of wave conditions. That might be less than the maximum or strongest wave fluxes that you can get on the planet. But some of these places are quite rough, and sometimes you don't want it to be that rough, because then you have to fold underneath the water many times, because the sea is risking your systems, and you get zero energy on that specific area or place, then you lose energy. But you can also look at in wave energy devices, or WECs, is a way to kind of maybe combine it with wind energy or even solar energy. So in the same rig or system, you can also have, say, wind over the WEC device. There can be a tower or something with some wind mill or something that can extract wind energy, and maybe a few water floating solar panels that is cleaned by the water, say, and is like encased in some glass or epoxy or fiber resin, that it is totally watertight, and there will not be any water ingress in the electronics or electrical connections there. So as I say, hybrid systems, or basically hybrid systems, can be a good solution. If it's not so viable to do it hybrid, then singular. Obviously, wave energy, if you can go for high pressure seawater, for instance, or something like in the, or direct electricity, but obviously it will not be 50 hertz. To format that to 50 hertz and the right voltage, it will be difficult if you do direct electricity. So I would rather prefer an intermediate form like high pressure seawater of a certain pressure, and obviously the transfer becomes more efficient if you make your pressure in relationship to your volumetric flow rate, because volumetric flow rate times pressure is basically power, and volume displacement times pressure is energy. So if you your volumetric flow rate, that doesn't really matter, and your fluid is heavy like water, it's easy to impact the turbine and to turn it. Like air is hard because it's compressible, and gas turbines is generally much more expensive than simple water turbines. Pelton wheels, whatever kind of turbine you want to use, but a high pressure Pelton type wheel or a jet on a thing that spins is kind of very effective way. But there are some other turbines that's also quite high pressure and quite efficient. But you've seen what a high pressure water cutter can do for your thin nozzle. It goes through steel and everything. I will not say everything, but the thin things. It can even cut diamond. If you go in a gigapascal range, 100 gigapascal water pressure. I want to know how that pumps work and what kind of pumps they use, but it must be some special pumps and some special nozzles and even some special pipes they use. But whatever, water can cut through diamond. So obviously high pressure water can carry a hell of a lot of energy. They can go through thick steel at high pressures. So if you can transfer energy with water, like seawater, it's beautiful. Now, obviously, seawater can be made like you can add some compound, some organic that easily breaks down, no detriment to the environment, that can make it slimy, like to smear your cylinders and to reduce friction. You don't want a lot of friction losses or stiction losses. So that is obviously would be optimal for any cylinder kind of setup. As I say, a normal shock absorber just uses a damper. It's not only a spring, it uses a damper to get rid of energy in the form of heat. And that heat is just like dissipated, and that's how it actually absorbs the energy of the rough terrain you are driving over. But there's much better ways to like use that energy and to charge a battery at least, or to at least get it back. Now, for alternative energy, that's exactly what you want. We have to see it's like a rough road, it goes up and down and moves all the time. That waves definitely is extremely useful to extract energy from. Whereas this 2000, 3000 watt, I don't know exactly how long our coastline is, but a lot of it, like 2000 miles, kilometers of it, is maybe possibly usable for wave energy. As long as you don't get in the way of boats and sea lanes. But I mean, fishermen can adapt. You can have gaps where they can get their boat through, or there can always be gaps between the units. You can have lights on these units, LED lights that don't waste too much energy, and some warning lights should not definitely warn people. You should not go in the mist on the sea anyway. So there's no real chance of people colliding with this. Um, and they can be made to be visually pleasing at least, or even, well, like, I don't like subsurface devices. They're generally not very efficient. But yeah, I just want to say this. We need this research institution or group. I would love to be like high up in there, because it's all like my idea. I don't want us only to use academically, like people with high degrees. You get some people that has no high degrees, but they have a very good common sense. It's like similar to me for this, and I'm only got a higher diploma by chance, because I was lucky. Many people can have even better insights. We must remember a guy like Albert Einstein, he never had a high degree when he came up with the relativity theory. He was just the right man with the right idea. So if we exclude people that show promise, we're going to make a big mistake. Not everybody goes to university with a good mind for this kind of thing, but they should now learn the basics, and they should show promise. And I think we should not exclude anyone that is interested, and we must obviously they must pass a test of some sort that is